The fifth question is, what is the greatest prime number between 1 and 10? First of all, tell me what are all the prime numbers between 1 and 10. So these are, first is 2, then 3, then we have 5, then 7, then 11. Wait, 11. It's more than 10, right? So we are not going to consider this. So the required prime numbers are 2, 3, 5 and 7, right? So out of all these prime numbers, we need to find out the greatest. Greatest what? Greatest prime number. So the greatest of them is 7. So the 7 is our answer. Okay. So our answer is 7. Okay. Let's move to the next question. Question number 6 is, express the following as the sum of two odd primes. Here what we need to understand is this part. As a sum of two odd primes. Two odd primes. Which means, for example, the first part is 44, right? We need to express this 44 as the sum of two numbers which need to be prime, as well as both these prime numbers must be odd as well, right? Okay, so let's start. So first prime number we know is 2. Okay, so can we write 44 as 2 plus 42, right? But here is a problem, right? First thing is 2 is a prime number, that's okay, but that is not odd prime number. Okay, right? So we are not going to consider the 2 prime number. After 2 we have 3, right? So 44 can also be written as 3 plus 41, right? Now we have to check this condition whether both the numbers are odd primes or not. First is 3. 3 is a prime number, right? And 3 is odd number also, yes. So the next is 41. 41 is prime, yes. Okay, we need to remember the prime numbers up to 100 at least. Okay, so 41 is prime and 41 is odd as well, right? So this is our required answer. Next is 36. Next part is 36. So again we are not going to consider 2. Now let's try with 3. 36 can be written as 3 plus 33, right? Okay, now tell me, 3 is odd prime? Yes, 3 is an odd number and 3 is prime as well. Okay, similarly check for the next number, which is 33. Is 33 odd? Yes, but is 33 a prime number? No, right? So our condition is not met, right? So we are not going to consider this. Okay, so after 3, the next prime number is 5. Okay, so 36 can be written as 5 plus 31. Okay, so now here tell me whether 5 is odd? Yes. Whether 5 is prime? Yes, we know. Okay, so the next is 31. Is 31 an odd number? Yes. Is 31 a prime as well? Yes. So both the conditions are satisfied. So this is the required answer. Now third part is 24. Now let's try to write 24 as sum of 3 and 21. 3 is prime number, 3 is an odd number also. But is 21 a prime number? No. Again, we can't consider this, right? After 3 we have 5. Okay. So 24 can be written as 5 plus what? 5 plus 19? We can write this, right? 19 plus 5 is 24. Okay. So 5 is odd? Yes. 5 is prime? Yes. 19 is odd? Yes. And 19 is prime? Yes. So this is the required answer. So D part, 18. Again try with 3 first. 18 can be written as 3 plus 15. Okay. So 3 is odd, 3 is prime as well. Okay. But is 15 odd? Yes. But is 15 prime? No. Right? 15 is not a prime number, right? This is 15 is a composite number. So we are not going to consider this. After 3, let's try with 5. 18 can be written as 5 plus 13, right? So 5 is prime? Yes. 5 is odd? Yes. 13 is prime? Yes. 13 is odd? Yes. So this is also the required answer. So the next question is question number 7. Give 3 pairs of prime numbers whose difference is 2. Whose difference is 2. This is a very important question because we are asked about the prime numbers whose difference is 2. So there is something which is called, there is a term which we call as twin primes, right? Twin primes is what? Twin primes is the pair of two prime numbers whose difference is 2. Okay, so which means we can also be asked this same question as give 3 pairs of twin prime numbers, right? Because the pair of numbers whose difference is 2 are also called as twin primes. Okay, we need to understand this very carefully because this can be asked in our exams as well. Twin prime numbers are the pairs of prime numbers whose difference is 2. Okay, so indirectly here we are asked about the twin prime numbers. So let's try to find out twin prime numbers. Let's try to start from 2. So first prime number is 2. Okay. Let's write some prime numbers first. 2, 3, 5, then 7, then 11, then 13, then 17, then 19. Okay. What we need to find is the pair of prime numbers whose difference is 2. Okay. So let's try to subtract 2 from 3. 3 minus 2 is 3 minus 2 is what? 1. So this is the not required one. Okay. Now let's try with 3 and 5. 5 minus 3 is 2. So this is the what we need. So 5 minus 3 is 2. So which means 3 and 5, this pair is twin prime or the required pair, right? So after that try with 5 and 7. 7 minus 5 is what? 7 minus 5 is 2. Okay. So this is also the required thing, right? So this we have found 2 pairs. Okay. Now try 11 minus 7. It will be 4. So this is not the required one. And now try 13 minus 11. 13 minus 11 is 13 minus 11 is 2. Again, this is what we need. Okay, so how many number of pairs we needed is 3. And we have 3 pairs, which are 3 and 5 from here. Okay. Second pair is 5 and 7. Right? And the third pair is 11 and 13. Okay. So this way we found the 3 twin prime numbers pairs, right? Okay. So let's continue to the next question. Question number 8. Which of the following numbers are prime numbers? Let's try to find out. Is 23 a prime number? Yes, we all know 23 is a prime number. Is 51 a prime number? If we divide 51 by 3, then it will be 3, then 21, 3, 7. 21, which is 0. So which means 51 will be having the factors 1, 3, 17, 51, but there can be other factors as well, but at least from here we are getting to know that. So here we understand that 51 is having more than 2 factors, right? So this is not a prime number. Okay. Is 37 a prime number? Yes. Is 26 a prime number? No. Okay.